Hey. All right, so we talked a little bit about calcium and magnesium last time, so we're going to head right into sodium and potassium today. So, sodium along with potassium. Sodium is found in all the body cells as well as in the blood and other body fluids. Sodium, along with potassium, helps to maintain the body's fluid balance, and sodium plays a huge part in nerve transmission, in muscle contraction, and in the creation of hydrochloric acid. Um, Now, sodium tells us a lot, and it's the first mineral that we waste under stress. It's the first thing that's going to tank in your clients that are having stress responses. So when we talk about sodium playing a huge part um, in nerve transmission and muscle contraction, I'm going to give you a chance. What is the other mineral that plays a part in muscle contraction and does the opposite? Anybody know?
Is it
So it's potassium
magnesium?
or calcium.
Potassium?
Oh my gosh, you all spoke at the same time. Somebody said it.
Potassium or
Magnesium?
calcium.
Calcium.
Ah,
Calcium.
Said calcium. I've got a chat here too. So,
yeah.
all right. Yeah, calcium. Um, so, knowing the answers to questions like that, how the minerals work together, which ones we talked about that, right? The synergy and the antagonistic relationships between minerals and knowing that's important. Um, so, as we go through and we look at some of these things and we look at how each mineral, what some of the symptoms are when we're low or, when things are out of balance, that's really can be really important. Um, so sodium deficiencies. Normally we don't see a lot of deficiencies, but when we do, especially when people are eating super, super clean, they might not be adding, when you're having a sad diet, those foods are really chock full of sodium. But when you're eating clean, sometimes you can see, people just really have taken that no sodium myth to heart and are really avoiding it. So when you think of sodium deficiencies, these are the things that you're talking about. Um, Dehydration, allergies, fatigue, anorexia, low blood pressure, apathy, low stomach acid, bloating, poor protein digestion, depression, dizziness, weakness. These are all things we have to consider. We're not looking blindly at this. We do have test results to look at, but you need to understand in relationship what this means to the other minerals, right? Um, so let's look at potassium. Potassium is needed for the proper functioning of a cell, for muscle contraction, carbohydrate metabolism, nerve impulses, energy metabolism, and to balance hypertension. Potassium is also closely related with cortisol levels. Um, Potassium is very, very underrated, I think. We don't spend enough time being concerned about it. Everybody, talks about magnesium and sodium and a little bit about calcium, but I think potassium often goes under the radar, right? Um, so I know like Dr. Berg's electrolytes has a higher potassium level in it. I think Ultima does too, has the lower magnesium and the higher potassium. Um, but people complain, right? Because potassium minerals generally don't taste good. Um, but when you put it in a drink, they've been clever. Like some of the things that they've put together, they've been pretty clever at hiding those things. So I think it's good. So you know, I think we need support with our potassium levels. So it's good that those are in there. And it's just like, we can get sodium from Soleil water, but we have to think in terms of balance. When we take selenium, for instance, we always make sure that we have iodine and selenium together. We want balance and we don't want one to push out the other. And potassium is needed for proper functioning of the cell. And we think about the sodium needs that are there with the things that they do, um, you need the potassium to be able to balance it. So um, we can lose potassium under stress, and with detoxing, So we need vitamin A from animal sources, think cod liver oil, eggs, butter, and organ meats to help retain potassium. Right, potassium
So can you
deficiency. Go ahead.
elaborate it all?
Can
I was
I?
just going to say, can you elaborate it all where it talked about it being related to cortisol, potassium?
Um, I think we get into it a little bit in some of these other slides. So, um, if I don't hit on it, we can certainly do a dive on that one. Okay. Um,
Okay, great.
oh, just remind me if I don't go back to it. Potassium plus cortisol. Sorry, my brain is definitely feeling the effects of all the stress that I am under lately. It's tough, so I apologize. So potassium deficiencies. I've got my salt right here. So I had my daughter, I'm like, go get me a packet of salt. I need some element right now. Anyway, potassium deficiencies, excessive thirst, irregular heartbeat, insomnia, depression, dry skin, salt retention, anxiety, depression, low cortisol, fatigue, brain fog, constipation, numbness and tingling, limbs constantly falling asleep, weak muscles, bloating, allergies, low blood sugar, especially upon wakening, and sugar cravings. Um, and really cravings of any kind can be caused by potassium deficiency. So, keep this in mind. We're not looking at potassium on a blood test result to show us dietary intake, um, because sodium and potassium are being regulated by aldosterone. So those levels are tightly regulated, just like serum magnesium is regulated, and the body's going to pull magnesium from anywhere to keep the blood at a certain level. And so with potassium, we might get excessive thirst and all these things. Um, this, I don't know, it sounds like a very typical client to me. Does it not? Like, we couldn't, I have a lot of these all together when I work with clients. Um, so this is where the concept starts to change, right? When we think of minerals, even when we think about vitamins, we're able to visualize what's coming in through the food, what's being absorbed through the gut wall. But, do you guys really have a clear picture of what this looks like on a cellular level? Like what is going on in and around the cells? Um, So let's answer that. When we think of sodium and potassium as they relate to the cell, where do each of them generally live? Anybody know? Silence. All right. Um, so when you look at a typical cell, sodium is going to be outside the cell and potassium is going to be inside the cell. And they live in this perfect little relationship. And they're pretty much in an equal amount. Potassium's probably a little bit higher. Um, so here's a good visualization for you. When you have a cell, right, obviously it takes energy, and this is the little sodium potassium pump. And you're going to have more sodium outside with a little bit of potassium, and more potassium inside with a little bit of sodium. And sodium ions are pumped out of the cell, and potassium are pumped in. And the energy is released by the hydrolysis of ATP. So ATP gives up the phosphorus and goes to ADP, which drives this pump. Um, so this is another visualization of this, right? So here you have the ATP, right? Adenosine triphosphate. You have the sodium outside and the potassium inside. So this goes in, the phosphate links on here to open it up on this side, right? Sodium goes in and fills those, and then it switches. The sodium's released to the outside, and then the potassium's brought in, and it goes back the other way. Phosphate's released, and it goes back. Everybody kind of can visualize how that happens.
Yeah.
Because I think it's important, right? We talked about visualizing digestion, like what happens when you chew your food, what happens after you swallow your food, what happens in the stomach, and really having a good idea of how those things function. And when clients come to you and have issues going on, then you can say, you can walk them through the digestive system. So it's the same thing with this. You really need to start visualizing how this stuff works and not just memorize, oh yeah, sodium's here and potassium's there. And, there's these little pumps and you think it just happens, right? This is, 3 sodium, 2 potassium, you need ATP, and you start talking about, when there's mitochondrial dysfunction and there's not enough energy to make this happen.
I think what's so interesting is when you think about all this, your picture is one cell. This is happening in every single cell
Oh, and there's
in your
more than
body.
one just pump, right? And this is your cell
Right.
membrane, right? The fatty lipids, that have, water on the outside and the fatty in the middle. And, stuff just doesn't happen willy-nilly. It's all controlled and it's all balanced. And what happens when your clients really, are on those low sodium diets?
Really makes you appreciate what a miracle the body is. It's incredible. Joe, in B, what is that little red explosion about?
That's the hydrolysis that releases one of the P's from ATP to make it
Thank you.
ADP, and then that, right, adenosine triphosphate here, right? So adenosine with the 3 phosphates, and then this is adenosine diphosphate, and the phosphate that opens this channel allows the sodium to go out of the cell, and then the potassium flows in, the phosphate's released, and then it closes and releases the potassium inside the cell and blocks on the other side.
Thank you. Are there any videos of that anywhere, Joe,
Oh,
where you can actually
probably,
watch it?
probably. There's probably, I
That
mean,
always
it's not,
me.
I don't think it's a video of what's actually, I don't know if it's a real cell, but I'm sure there's some, you know,
No, but kind of like this, like a
yeah,
cartoon. Sometimes watching it makes me understand it better.
yeah. Well, here's the slideshow of it.
And thank you for the explanation.
Yeah, no problem. So, you know, a healthy cell, there's the same thing. So it's important that we have the good ratio of sodium and potassium, but the same thing happens with calcium and magnesium. Proper magnesium levels help keep calcium levels in check in a healthy cell. But if you have magnesium deficiency, then it's going to allow too much calcium into a cell. So the same kind of thing happens where, we need to make sure that we have a healthy balance. And there's different ways, right? There's passive transport and then there's the active transport. So a lot of things will just diffuse across the membrane, right? Where you have um, solute, things that are dissolved in fluid and across both levels of the membrane. You want to have good equal amounts and they'll just diffuse across the membrane. That doesn't really take any energy at all, but then because it's passive, right? Or there's facilitated diffusion where there's just specific channels that only let one thing in or out of the cell. And then there's active transport that takes that ATP, like the sodium potassium pump, where it takes energy to make that transport happen. My mini biochemistry lesson for you, cellular biology. I think it's really important if you guys don't have a science background to go through and I know Jen had linked to some coursework, and I'm going to be putting some of those. Carolyn keeps coming in and out. Welcome back, Carolyn. Um, I'm going to be linking some of those classes to really get a good understanding because I think it's important that we understand some of the physiology that we may have missed. I know I don't remember all the physiology. I know that when I was in biochemistry classes back in 1988, 1987 in college, they didn't know how water made it across the cell membrane. Like it just magically happened. They knew it didn't just diffuse, but they couldn't find the actual mechanism. They didn't know how certain things, like it was still a mystery to things basic like water and oxygen. Like they had some of the stuff was identified, but some of it wasn't. So, you know, there were mysteries that have been solved since I went to school. So, um, all the things that we're discovering. Um, So anyway, I think that I will be linking some of those classes too this year, so you guys can selectively go through and in all of your spare time, maybe you don't know about why these are different and want to do a deep dive into that. So another interesting aspect of the sodium potassium pump is that they're involved in kidney function, and in fact, without them, it would not be possible. So the kidney filters 180 liters of plasma every day. Remember, plasma is that liquid part of the blood, the solution part, which contains substrates that must be excreted while others must be reabsorbed so that they're not lost through the urine. The reabsorption of sodium, water, and other substances depend directly on the sodium potassium pumps, which are found in the tubular segments of the kidney nephrons. You guys, I think, was it SAFM where we went through that and they had the little diagram? Or am I remembering it from something else?
No, I think it was SAFM.
So, and like kidney function is one of those things that it is so like if you're going to watch a video on something, watch a kidney what on, because with all this hydration and dehydration and how aldosterone works, really like getting a handle on kidney function. I mean, we may be able to do an entire probably class on the kidneys and how they regulate things because it is really kind of an amazing little organ. Blood testing can be a real complement to HTMA. So on a blood test, what can we gather from a low sodium and an optimal potassium? Anybody want to jump in?
I don't remember if it's low sodium and optimal potassium, but I think you could check for hypoadrenal.
Mm-hmm.
One of them is about adrenals.
Right. So with sodium, it's likely more of an adrenal. So it can tell us what aldosterone is doing and what stress levels are. So for sodium, it's likely more of an adrenal downregulation, and then with low potassium and an optimal sodium, it would be the opposite, more of a hyper. I believe that's the way it goes. So in a low adrenal situation, low sodium and low potassium, we might be thinking about cortisol. In a hypoadrenal, there's going to be an issue with too much stress, one favoring being more chronic in the way we have to look at it. So low sodium with a higher potassium is more chronic, and then high sodium with low potassium could be a more acute state. Um, so, those things demonstrate the stress response, and we can take a look at what the cell is doing when this is happening. So let's talk about a hyperadrenal stress response, right? It's going to raise aldosterone, which is going to cause the kidney to reabsorb sodium. Excess sodium is going to be pulled into the cell. And when you get excess sodium inside a cell, it's going to push that magnesium and potassium out. Everybody understand how that works?
And so that means that in the blood, the potassium would be higher, correct? Or no?
Right. If it's pushed out of the cell, you could have higher than potassium on the blood work. So an HTMA can measure minerals both retained in or excreted from cellular storage. So calcium and sodium should be extracellular, and magnesium and potassium should be intracellular, right? If everything's functioning correctly, that's where, so you have to like kind of know like where do these things live so that when you're looking at um, the HTMA, what you've got going on. So that's just one scenario, right? This pushing, the hyperadrenal stress response is just one scenario that can cause minerals to flow in certain ways. So so this is a calcium magnesium inversion on an HTMA with a high sodium potassium ratio. So if you're looking at this, when you see calcium low and magnesium, almost 4 times as high as it should be, or 3 times, and the same with sodium, where potassium is low and sodium's up here, what I want you to do is realize that this is, obviously this is one of the first ratios scenarios that you guys are playing with because you're pretty new to this. But what do you think this might mean? Give me a scenario based on what you know and what we just talked about. What might be going on here?
Well, if they're in a hyperadrenal state,
So why?
because the magnesium is being excreted, not being taken in.
What about the sodium and potassium? Anybody? So, you want to try and figure out what is happening and why someone might have more magnesium and sodium in their tissues and why they're being excreted in the body. So what belongs in the cell should be in the cell unless it's forced out into the tissues, and hair is part of that tissue. So when we see a lot of severe stress pushing sodium into the cell where it doesn't belong, because there's so much sodium in there, the system is flooded with sodium and it's in the cell, it's in the tissue, and we know it's in the tissues because we can see it here. So we have a body full of holding on to sodium and retaining it, and it's got to go somewhere. So it's being forced out and it's being forced into the tissue. So we see it high because we know it's high because it's in the hair tissue. And then we know it's high, and then confirming that because the potassium is low. So that's one reason. So when sodium goes in there, it's going to force the potassium out. And we have that understanding, just like a few slides ago, that the body's holding on to sodium but excreting potassium out through the urine. So we're not seeing potassium in the tissue because the kidneys are filtering it out in the urine. So that's more of an acute stress.
So Jen, see, I told you, you're Joe, you're Jen's meaning me. Ah, question. We give sodium all the time,
Mhm.
in water to absorb it. So does that screw any of this up, or is it completely unrelated because of where the sodium is?
No, the kidneys, the aldosterone is going to control that, right?
Okay,
I
thanks.
mean, in a functioning body, right? We said that you can't get too much salt because in a functioning body, the body will excrete it, right? The kidneys will do what it needs to do. But when we have a situation where the body's under stress and things are happening opposite, you're going to get some of these inversions. You're going to get some of these things that happen because it's not correctly functioning. So when sodium's pushing into the cell, what else has to get out besides the potassium? If we have a high level of sodium, we're going to lose the magnesium too. And it's here in a large amount because it should be in the cell, right? And it's not. So we're losing magnesium also. And then we know that the body has a tendency to hold on to calcium. So if magnesium's lost, then calcium is going to be inside the cell where it shouldn't be, right? Because it's going to be that unhealthy cell again. Where's that picture? Here, right? So with proper magnesium, it keeps calcium in check. But if we're going to have that inverted ratio, the calcium is going to be stuck inside the cell and we're going to see a loss of magnesium.
So then what does it look like whenever you have that calcium shell? Is it just an extra excess of calcium?
Yes. And we're actually going to get into that, but we have to understand this first, right? Get a really good idea of that. But yeah, that's actually part of the next thing. So just like blood work, HTMAs can have patterns that hide the real picture, right? You're looking at this and at first glance, you're going, oh my gosh, there's a lot of magnesium and a lot of sodium, but it's a loss pattern, right? The body can't hold on to this. There's too much extracellular. It's, so this isn't really a true quantitative, right? There really isn't 4 times as much in the body because the body's excreting it to try and keep them more in balance.
Joe, I have to ask a quick question.
Mhm.
I
I
keep
will try to
finding
give you a
myself,
quick answer.
I keep finding myself when we're discussing this and then the blood work. Do you just keep them absolutely separate? Because I'm seeing high magnesium, high sodium, and I know it's telling a different story in the hair, but
Mhm.
then okay, so what is it in the blood? Do you
So
just absolutely keep it separate? I get confused.
no, you have to realize that the blood has to keep things tightly regulated. Think of it as a highway, right? There's only so many cars allowed on the highway. And you're going to have some semis and you're going to have some little, some little VW bugs and you're going to have some minivans and some SUVs and some motorcycles. But pretty much there's only so much room in the highway. And if the highway if it's not balanced, it's not going to work. So when we look at blood work, you're not able to see as much of, these huge differences, because the blood wouldn't work. It wouldn't be able to function as a transport that we need it to. So yes, you're going to see small fluctuations in blood work, right? And if you look at a blood chemistry, right, that has low magnesium on it, and then you come to here and you see that it's high, it's because the body it's not able to hold on to that magnesium. It's excreting it out through the hair because it can't hold on to it in the blood. Does that make sense?
So your blood magnesium could be low, even
Right.
though this HTMA looks elevated.
Correct. And
Okay.
that's one of the clues to know that there really truly is some level of deficiency.
Okay. Thank
Right.
you.
And it's not because they're not is it because they're consuming too much? You've got to, that's where it's not at face value. You have to know your client. You have to know what their diet's like. You have to know if they're taking gobs of magnesium supplementation. Like, what's going on? Who is this person? It's like looking at a low protein on a lab, but you know that they're eating a carnivore diet, or looking at a low protein on a lab that is a vegetarian. That lab is going to mean different things to you based on who is this person. But what I'm trying to teach you right now is, what does calcium and magnesium and sodium and potassium do in the body? How do they move around? How does the body regulate their levels? And why would you then see this pattern? What is it telling you about what's going on in that person's biochemistry? It's just one piece of the puzzle. It would be really great if we had a lab that just explained everything about our client, but there really isn't one.
Could you kind of look at the HTMA like a hemoglobin A1C, almost like a certain time period memory of what's been going on, like a history or not?
Yeah, because you're looking at hair growth that, how long did it take them to grow the sample that they turned in? And it locks that in. The slide last week showed, we showed the hair follicle. And the hair follicle, is nourished by the blood and the lymph and the extracellular, what's hanging out around the cell. So if we know that we have a lot of sodium hanging on outside the cell, how is that affecting what's going on? If it's not able to be in the cell where it's supposed to be in a healthy cell because something else is going on, right? We're going to lose it. The body's got to do something with it. All right. I do not have people home to let my dog out, and she's scratching at my door. Hang on one second, guys. Let me figure this out. What's going on? Get to go outside. Come on. Probably a feral cat or a squirrel in the backyard that she has to go vanquish. All right. So once again, it really helps when you're looking at these patterns to visualize what's going on in the body and why these patterns would exist. Back. So just like blood work, HTMAs can have those patterns that hide the real picture. Here's another one, right? So you've got the calcium magnesium inversion here. I don't want to confuse you anymore, but this high magnesium here means that it's not in the cell and is being pushed into the tissue. But then that means there's really a tiny amount of magnesium inside your cell. So that's what you need to consider. And if we're looking at this picture, um, it's just like when we look at dehydration, right? And you see numbers that are elevated, but they're falsely elevated because you're looking at a dehydrated sample, right? So go ahead.
Oh, no, I didn't have anything.
Did Kristen say something?
Nope, I'm
Thinking out
quiet.
loud? Okay. So, so same thing here, right? You're going to, if there's little magnesium, right? If you, this is a graph in the early stages of stress, right? When your body's just really doesn't have, you're losing the magnesium and there just isn't any magnesium to be had. And then you've got higher levels of sodium and smaller, so you're losing, you've lost magnesium. It's in the beginning stages. Sodium's up because when you look at, I wish I had these, like I keep having to like go way back, right? Um, back, right? If you're going to be losing sodium and you're going to have a lot of sodium outside of the cell, you're going to end up drawing out magnesium or not having magnesium either. Um, I don't know if there's a good, I don't know if I have a good slide for that. I lost my place in my notes. Sorry, guys. So, I mean, you're not going to be able to just look at an HTMA and be able to say, well, we need to give this person magnesium or we need to give this person, potassium or whatever. Is that going to work? Like in this situation, if we have a magnesium loss and calcium is being retained, what if we gave this person more magnesium? Is that going to help them? Can you answer that question for sure? Just looking at this HTMA. Um, you're not going to learn enough just looking at 4 minerals to be able to answer that question. So healing is going to happen in stages, and there's a huge difference between treating the illness and healing what's happening in your body. Um, so with calcium and magnesium, when you have a magnesium deficiency, um, the body's more likely to retain calcium. So this is similar to the relationship of sodium and potassium. Too much calcium is going to block magnesium, is going to create a deficiency. So you have to ask yourself, why is my client not absorbing the magnesium? If if they're taking it and they're still having symptoms, maybe there's too much calcium involved. So, and this is where, Maggie, you talked about the calcium shell, right? So excess calcium and low magnesium, that's going to create a dynamic and it could create glucose dysregulation and raise insulin. And, where can we find that information? If you're going to look on a blood test and go, is this hypothesis, like you see this on an HTMA and you want to know, is it creating glucose dysregulation? Is the insulin going up? This kind of situation, it's going to increase cravings, it's going to increase muscle spasm and aches. and pains, right? Because you're going to end up with that calcium inside the shell and not enough magnesium. So, does anyone know what marker you would go to check this glucose dysregulation?
Um, the one for HTMA or in the blood?
In the blood, in a blood test. So you've looked at an HTMA, you've got a high calcium. This is inching towards a calcium shell, right? And we'll talk about that next. My next PowerPoint it goes into calcium shells a little bit. But this is definitely a pattern that is going to cause glucose dysregulation, having the lower magnesium and the higher calcium. So if you wanted to know if this was actually happening for your client and you had some good comprehensive labs, what would you look at?
Did you look at the hemoglobin A1C?
You could. Yep. Where else?
The insulin, fasting insulin.
Yep. Fasting insulin. Anything else? How well is a cell using the glucose? What marker tells us that? I don't know if I learned about this one at SAFM. I think I learned this one from Jen. So Maggie and Kristen, you might be the only people that could answer this one.
Is it the one that starts with an S?
Fructosamine? No, fructosamine's more of if A1C is not reliable, fructosamine could be a fallback. So if they're super dehydrated and their red blood cells aren't making hemoglobin and then the A1C, then because it's right, glycosated hemoglobin, you could use fructosamine instead. No.
Would you use a fasting blood sugar?
You could use fasting glucose, but I'm thinking about lactase dehydrogenase because that's going to give us insight into how well the cell's actually using the glucose. And then you could talk, the symptoms, right? The cravings, the muscle spasm, the aches, that all can also be there.
Yeah, I didn't learn that. Now I'm remembering Jen talking about it.
Yeah. So, yeah, there's a lot of markers, that Jen has on her panel that we're going to get into when we do more deeper dives into blood work, but I don't want to confuse everybody. But LDH is a marker that I think I've seen it on blood panels that other people have run when clients come to me. So you guys can Google that one, but LDH. But this is a thing. Oh, I'm getting a call from somebody at the theater. Anyway, I am almost done, but hang on, guys. Sorry. Let me mute myself. Hi, sorry, guys. Problems with the steam mop for the lobby. I'm like, I don't know. Anyway, once this pattern starts, then we have to pay attention because this can very easily turn into a calcium shell because because calcium is going to leave, this is a sign of what's happening in the tissues, right? So calcium's leaving the bone, it's hanging out where it shouldn't be, and you're going to end up with calcifications, and tissue calcifications. So